Okay, we're going to talk about section 11.2, finding limits using properties of limits. You will find one in this section quite nice and easy when going through here. It's not a too hard a section to work with. Our objectives of this section is to find limits of constant functions and identify the function. Find limits using properties of limits. Find one-sided limits using properties of limits. And find limits of fractional exponents in which the limit of the denominator is 0. So let's look at a few things here. For the constant function f of x equals c, constant means it just equals a number. The limit as x approaches a of f of x is equal to c. It's that constant. Where regardless of what number x is approaching, the limit of the constant is that constant. So for example, if we're looking at this case here, the limit as x approaches 8 of 11 is 11. And the limit as x approaches 0 of a negative 9 is a negative 9. It's always equal to that constant. Now, if a function is equal to a variable, x, and as x approaches a is just a. So, for example, the limit of x as x approaches 19 is 19. The limit as of x as x approaches a negative square root of 2 is a negative square root of 2. The limit of the sum. The limit as x approaches a of f of x is equal to L, and g of x as x approaches a is equal to m, then the sum of the limits is equal to the limit of their sums. So we can break them up as long as they're approaching the same value. In other words, the limit of the sum of the two functions equals the sum of their limits. So for example, in this one, the limit as x plus 16 of x approaches a negative 3. What we can do in this one is to take out and split these up as limit as x approaches a negative 3 plus the limit of 16 as x approaches a negative 3, which is a negative 3 plus 16, which is a positive 13. Differences is set up the same way. The difference of the limits are to separate them out and subtract the two limits. So we have 19 minus x as x goes to 14. If we look at this, we're going to plug in 14. So we have the limit of 19 as x approaches 14 minus the limit as x approaches 14 of x, which is 19 minus 14, which is 5. Here's the pattern you're seeing. If it's a continuous function, we can just plug in this number and get our answer if it's a continuous function. Periodic, same thing. We're just going to multiply the two limits together and get our answer. Again, here's a negative 10 times x. So if we take this one and separate it out, the limit of a negative 10, this g is not supposed to be there, a limit of negative 10 as x approaches a 7 times the limit of x as x approaches 7, which is equal to a negative 10, because that's a constant, times 7, plug it in, which is equal to a negative 70. Powers, plug in the numbers and get your answer as you go. Limit of this, when we look at this, we can plug in the negative 2. Let's cover that up. Let's see, when I look at this, since this is a continuous function, we can think about this as the limit as x approaches 2 of a negative 7 times the limit as x approaches 2 of x cubed. Negative 7 is going to be negative 7 times, plugging that in, 8, which is a negative 56. If f is a polynomial function, the limit as x approaches a of f of x is equal to f of a. So in other words, if this is a polynomial function, it means it's continuous on the thing. We can just take in 2 and plug it in. So we get 7 times 8 plus 3 times 4 minus 5 times 2 plus 3. And we can just plug them in. So we're going to get 56 plus 12 minus 10 plus 3. 68. 71 minus 10 is 61. if the limit of f of x equals L and n is a positive integer, then it goes to that power. The limit of function to a power is found by taking the limit of the function, then raising that limit to the power. So in other words, we can just plug in this number, so the limit of this is going to equal 3 times 4 minus 5 to the third power, which is 12 minus 5, which is 7 to the third power, which is 343. Same thing with square roots, plugging in the numbers. So like in here, we can plug in the number into here and take the square root of that limit to get a value out. So it gets, if we plug in a negative 1, we get 6 times a negative 1 squared minus 4. 1 negative 1 squared is 1 times 6 is 6. Minus 4 is 2. It's the square root of 2, which is our answer. So we take, it's the limit of the square roots as you go through. And the quotient, we can divide two limits. And the key here, again, to remember is that the limits have to be going to the same value as you go through. And provided that the limit is not equal to 0. Now notice on here, we can plug in, if we plug in 2 in the denominator, 6 minus 5 is 1, so that's okay. So we get 4 minus 8 plus 1 over 6 minus 5. So we get negative 3 over 1, which is equal to a negative 3 as our limit. And this just summarizes all the rules we just talked about. Quotient and everything. Now in the previous section, we used graphs of piecewise functions to find one-sided limits. We could also find such limits by applying properties of limits to the appropriate part of a piecewise function. So in a one-sided limit, if we are asking this, let's say we're asking the limit of f of x as x approaches 1 from the negative side. Now if we're approaching 1 from the negative side, we're going to have to use this equation because it's less than 1. So our answer to that would be negative 1. Now if it's approaching f of x from the positive side, so we're going to use positive 1, which means more than 1, means greater than 1. We plug that in, we're going to get the cube root of 2 times 1, which is 2 minus 1 is 1, which is equal to 1. So the limit of f of x on here, let's look back here. So we talked about this, the limit of 1 from the negative side is going to be a negative 1. The limit of f of x from 1 from the positive side is 1. And so this limit does not exist. Remember, left and right side have to be the same value as you look at it. When taking the limit of a fractional expression in which the limit of the denominator is 0, it is necessary to rewrite the expression before the limit can be found. One technique can be used to rewrite the expression as a fraction, factor. So like in this one, if I plug in 1 into my denominator right now, I'm going to get 0. So what we're going to do is rewrite the top, so it'll be x plus 3, x minus 1 over x minus 1. Now we can simplify and get rid of that x plus minus 1. And now we can plug in 1 into our equation, 1 plus 3. We still have the limit as x goes to 1. So plug in 1, we're going to get an answer of 4 out as we go through. And that finishes off 11.2.